Good morning to one and all present here. It gives me immense pleasure to introduce the chief guest of this section, Dr. M.K. Ilango, Professor and Head Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. He is an eminent and enthusiastic researcher with over 15 international journal publications and has successfully presented more than 25 papers in various international and national conferences. He has an excellent track record of organizing more than 14 FDPs and has delivered nearly 50 lectures in various workshops. He has received a Best Teacher Award in the year 2011 and is a finalist for the Best Techo Faculty Award in the year 2016 and 2015. He has also successfully handled sponsored projects. He received his doctorate from Anna University in the year 2012 and 7 research scholars are pursuing research under his guidance. He is also first rank holder during his master degree in the power system at Annamalai University. Now I request Dr. M.K. Ilango to take over the section and enlighten us with his lecture.
Yeah, thank you, team members, for your nice introduction. Yeah, now we will go to the session. Before that, I will share my screen. Just a minute.
Sir, we can wait for 2.
Shall we start it now, Dr. Srividya? Hello, am I audible?
Yes, sir.
Hello?
Yes, sir.
Yes, sir. You are audible, sir. Yes, sir.
You're audible.
Yeah.
Please.
Yes, sir, audible.
Thank you. Dr. D. Srividya, kindly reply me. Shall we start it or we have to wait another 2 minutes?
Participants.
Yeah, hope it's the right time to start the session. Yeah, as a coordinator of ATAL FDP program, I'm so happy to take the session and the first session, the title Introduction to Electric Vehicle. I think the team member have introduced myself. Even though if they have introduced, let me introduce myself. Dr. M.K. Ilango, Professor and Head Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. I have completed my undergraduate program in the year 1997, and I received the degree from Madras University. After getting the degree, I have joined as a lecturer in K.S.Rangasamy College of Technology. And during the period 2002 to 2004, I was deputed to do my higher studies. I did my higher studies in Power Systems Engineering in Annamalai University, and I received a university first rank holder from Annamalai University. And in the year 2006, I was registered my PhD in Anna University, Chennai. And in the year 2011, I have completed my PhD degree. Right. So I hope more than 23 years of teaching experience in engineering colleges. I have worked in various positions like lecturer, assistant professor, associate professor. Uh, Currently, I am working as a professor and head of the department. Okay. In today's session, I would like to give the explanations about the following title. When we look at the contents of Introduction to Electric Vehicle, first I would like to give the definition of electric vehicle. Actually, what is the electrical vehicle and how it is different from internal combustion engines and all, right? Then I would like to give what are the energy sources used in electric vehicles. We see the very important aspect of electric vehicle is energy sources. So what are the energy sources available in electric vehicles, and what about the comparison of different energy sources and classifications of various electric vehicles? What are they, and what about the system configuration of PEV and the system configuration of HEV, and finally the comparison of various energy sources in vehicles used. Right? I hope
Hello,
our disturbances from
excuse me, sir.
right. Mute
There
your
is so much of disturbance.
audio. Can you mute the participants' audio? Right? Okay.
Thank you.
Yeah, thank you, sir. Yeah, when we look at the definitions of various electric vehicles, the first one is the PEV, that is the pure electric vehicle, and another one is the hybrid electric vehicle, right? See, yeah, the pure electric vehicle that has only the motor and the battery, right? We know that without having any energy sources, we are not going to run the motor, right? See, motor is that definitely we are in a position to give some input to the motor, right? See, with the help of a battery, we are going to give the supply to the motor, and with the help of a motor, we are going to run the vehicle. That vehicle is called as the pure electric vehicle, right? Whenever we go for a hybrid electric vehicle, that is the combination of both, right? See, nowadays we are most of the people we are using internal combustion engines vehicles. In addition with that internal combustion engines, if I had to use one more motor and battery supply to give this electrical supply to the particular motor, this is known as hybrid electric vehicle, right? See, I hope the enlarged figure is visible to all. See, this is the diagram. It shows the hybrid electric vehicles. That hybrid electric vehicles consist of the two machines, right? See, one is the internal combustion engines, and another one is normal like motor, right? This motor, it will be any synchronous motor or whatever may be the requirement, we have to fix it, right? See, whenever we want to run the whenever we want to run the vehicle with the help of electrical supply, we have to run with the help of motor, and which is derived power from the battery, right? Suppose if we are in a position not able to give the fullest electrical power to the particular motor with the help of internal combustion engines, if we are going to run the machines, right? So the machine which is going to operate by both by means of internal combustion engines and electrical motor, this is known as a hybrid electric vehicle, right? See, that figure indicates the blue color line indicates the electricity, and yellow color line indicates the fuel supply, and proportion shows in the case of a red in color, right? See, just it's like the normal fuel tank. With the help of fuel tank, just we had to fill up the fuels. It may be liquid petroleum gas, LPG, or diesel or petrol, whatever may be that. Nowadays, that IC engines are going to be used for multi-purposes, right? You may notice some petrol engines are going to be used with the help of LPG as well as the petrol, right? See, for that cases, whenever the particular engine is going to be operated with the help of LPG, we can fill up with the LPG. Or sometimes the same engine is going to be operated with LPG and petrol. So, two number of separate tanks are going to be used for fueling the particular IC engines, right? So, that particular IC engine is going to be operated with the help of fuel supply, right? And one more facility, with the help of a battery, the motor, particular motor is going to be operated, right? See, if it is so, the vehicle is called as hybrid electric vehicle, right? Instead of that, the vehicle have only the motor arrangement and the battery, right? If it is so, that particular vehicle is called as pure electric vehicle, and we know that battery we are going to recharge the particular battery, right, with the help of any household electricity. Even nowadays, then commercial plugging charging stations also come into the picture with the help of coming to the market. So with the help of them, just we are going to charging the particular battery, and the charged battery is going to drive the particular motor which is designed in the vehicle, and because of this particular vehicle is going to be operated, this is known as pure electric vehicle. So when we look at the definition of various electric vehicles, based on the operations, it's generally classified into the following two categories. One is pure electric vehicle and another one is hybrid electric vehicle, where hybrid electric vehicles means it's a combination of internal combustion engines and a normal electrical motor, right? So this is the definition of electrical vehicles, right? Then, yeah, battery. Then we look at the various energy sources used in electrical vehicles. The first category is the batteries. We all know, I hope all over the India, faculty members of electrical engineering are attending this program. So I don't want to give the explanation how the batteries are going to be functioning, right? So I will give some overall view about the batteries. Yeah, batteries is a collection of one or more electrochemical cells whose chemical reactions creates a flow of electrons in the circuits, right? So normally the batteries are going to be functioning in two modes. One is charging mode and another one is the discharging mode, right? See, actually when charging the particular battery, when the battery is charged, the lithium ion in the cathode material, that is lithium compound, migrates via separator to between the layers of carbon material that form anode and a charging current source. So while charging, all the positive ions gets accumulated in one of the particles that is called electrolyte, and another one negative charged ions are going to be separated out in the anode, right? So by the way, just we are going to uh, just we are going to grouping the electrons, right? See, when the same battery is going to be disconnected from the power supply and it is going to be connected with the load, what is this automatically the battery function is going to change from charging to discharging mode. When the battery is discharged, the lithium ion in the carbon material that form the another that form the anode migrate via separator to the cathode material, it is lithium compound, and a discharging current flows through that. So in that situation, what happens? All accumulated positive ions have to be circulated through the load circuit, through the load. Actually, here the load is going to be act as the electrical motor. One electrical motor is going to connect it with the cases, right? See, suppose for example, if the particular electrical motor is going to be function under AC, again, what they had to do that this supply is converted into AC. So depends on that type of electrical motor, we are going to use it, and accordingly we are going to change the conversions, right? So this is the uh, uh, batteries which are going to use in electrical vehicle, and the batteries are normally used in the following two modes: charging and discharging mode. Right. See, from this slide we can easily understand how the charging takes place, and during the charging, how the charges are going to be taken out. Right. With the help of a power supply, some potential differences, they are going to separate out the positive ions and the negative ions uh, through that chemical reactions, so that by the way we are going to charging, right? And discharging, automatically the charged particles separated out in separated group has to be disseminated. So the free electrons have to be moved through the circuit. By the way, we are going to run the electric vehicles, right? See, this is the first source, batteries, right? Then then the second case is a ultra capacitor or super capacitor, right? See, you may ask the question, sir, what is the difference in between ultra capacitor or super capacitor? Nothing. The same capacitor. Normally, we are using the capacitor for capacitor bank for reactive power compensation and all. The same capacitor is going to be used as the energy sources in electric vehicles. Only the difference of a normal capacitor and ultra capacitor is the rating, right? What is the rater? What is the rating of a capacitor we are using, right? See, for higher ratings of capacitors, normally it's called as ultra capacitor or super capacitor. Here, I think the animation shows how the ultra capacitor is going to be functioning, right? So, similarly, this is also going to separate out the positive charged particles and negatively charged particles in a separate uh, plate, and with the help of the potentials, right? See here, energy is stored up in ultra capacitor by polarizing the electrolytic solution. The charges are separated via electrode and electrolyte interface. The same actions, the same process is going to be happen in capacitors as well as in the batteries. Only the difference in batteries, with the help of chemical reactions, charged particles are going to be separated out and it will be moved in the electrical circuits. But in this case of ultra capacitors, they are not going to use any chemical process. In that, instead of that, we are using the polarizing the electrolytic solutions. We are making them into separate cases, right? See, again, it has the two functions. So one is charging functions and another one is discharging functions, right? Right. See, for charging functions, with the help of additional power supply, normally DC supply, which is going to use to store the charged particles. We know all well what is the capacitor, right? The capacitor is also, we can give the explanation just like a resistor, right? See, what is resistor? It's the property of a conductor which opposes the flow of current, right? See, various in inductor, we may give the explanation. What is the inductor? This is also the property of conductor which is opposing the rate of change of flow of current, rate of change of flow of current. In that aspects, we can give the definitions for capacitor. Capacitor is also going to be taken as the property of a conductor, which is separated by with the help of some isolation mode, and which is used to oppose the rate of change of potential differences. Right. So if there is any potential differences, and the rate is also going to be changes. That means the polarity of the voltage is going to be changes. What is this? Capacitance is going to be existing in between the conductors, right? See, it's separated by the two plates and in isolation medium, right? So, hope you understand what is the capacitors, right? So, in charging stations, what is this? Again, just like batteries, charged particles are going to be separated. See, positive charged particles are going to be separated in anode, and negatively charged particles will be separated in cathode, right? So, by means of these cases, just we are going to charging the ultra capacitors, right? So just if I had to apply the positive supply to the anode and negative supply to the cathode, so automatically the charged particles will be slowly getting into charges, right? Slowly, slowly, the free electrons from the battery, from the sources, from the DC sources has to be flow, and the charged particles are to be accumulated in the same plate, and finally it's fully charged, right? See, it will be charged till end of the free electron. See, for each and every capacitor, they have the capacity, how much amount of potentials are going to be stored, right? See, normally, if I have to take a small amount of capacitor, use it for electric vehicle, it is not going to drive the electrical vehicles. That's why we go for some higher ratings of higher ratings of capacitors, right? Named as ultra capacitor or super capacitors, right? So, with the help of DC sources, the charged particles are going to be separated out and accumulated in a plate, right? Just like a battery, right? See, then discharging, just we have to disconnect the power supply and it will be connected to suitable electrical drive. Suppose if you had to, what is this? If you had, depends on these applications, whether it is going to be used AC motor or DC motor, depends on that. We have to use some additional control devices. What is this again? In discharging mode, what is this accumulated charges accumulated in the same plate has to be disseminate the free electrons. So through that closed circuit, the free electrons getting loaded, right? See, just like capacitors, it is going to be used as another additional energy sources in electric vehicles. Okay. Then the third source is the ultra flywheels, right? See, what is the flywheels and what is the difference in between ultra flywheels? The same, just like capacitors and the ultra capacitors. Nothing, there is no difference in between capacitors and the ultra capacitors. Only that based on the rating we are saying. Just now, I explained to you that, right? Just similar to that, flywheels and the ultra flywheels, there is no difference in between them, right? See, based on the rating, what is the actual mechanical energy stored in the flywheel, right? What about the ratings? Based on this, flywheels have to be classified into the following two categories. One is normal flywheels and another one is ultra flywheels, right? See, ultra flywheels means what? That have what? That have more ratings, that have more specifications, that can store more amount of mechanical energy, right? See, actually, what is the flywheel? Flywheel is the mechanical device specifically designed to efficiently store rotational energy, right? Just like a capacitor. Capacitor is used to store electrical energy, right? Just like batteries and batteries, the capacitor is also going to use to store the electrostatic energy, right? Just like that, the flywheel is going to store the mechanical energy. Mechanical means that rotational energy is going to be stored. A flywheel is a mechanical device specifically designed to efficiently store rotational energy. Flywheels resist changes in rotational speed. For example, the particular tire has to be rotated in forward directions, that is the clockwise directions. The flywheel is not going to what is this? Flywheel resists the changes in the rotational speed. Suppose if it is going to rotate in anti-clockwise direction. Suppose if I had to change the gear and the particular vehicle is to be moved in reverse directions, the flywheels is not going to be flywheel is going to resist the changes in the rotational speed, right? By their moment of inertia, the amount of energy stored in a flywheel is proportional to square of its rotational speed and its mass. Just you have to imagine the particular vehicle is running, and just you have to consider the particular vehicle is is moving from top hill station to down hill station, right? Just like a slope, right? In that situation, it does not require a very high amount of energy to rotate the vehicles, right? See, normally due to the slope of the road, what is this? Automatically, the wheel has to be rotated, right? It's not going to require much amount of fuel for running the internal combustion engine, and it passes to drive the wheels and all, right? See, due to the slope of the road itself, it's going to run, right? So during this situation, what is this? Some additional mechanical power is going to be uh, getting from that vehicle. So in that situation, that additional mechanical power, that is additional mechanical energy, that is rotational energy, is going to be stored in the flywheel mechanism, right? and it is going to be utilized whenever it needed, right? If, for example, the vehicle is running in the roadside, we are not going to say that always the road will be in plain mode, right? Some of the particular area, the road may be in some upwards, and some of them may be in downwards, right? Sometimes it will be a combination of both the cases, right? So in that situation, whenever the vehicle is running in flow, downward roads, that additional mechanical energy is going to be stored in the flywheels, right? See, not only that cases, not only in that situation. Another one example is also with that how the flywheel is going to getting store the energy. Suppose, for example, if you had to run the vehicle in a traffic, right? See, normally the traffic during the traffic period, more than 30 seconds or more than even sometimes 1 minute and all, we are going to wait what is this in a junctions, traffic junctions. In that situations, we are not going to stop the engine. So in that particular situation, what the car is going to do is that additionally, unwantedly, the internal combustion engine is going to run, but that engine power will not drive the wheels, right? So in that situation, uh, instead of running the wheels, that power developed by the internal combustion engine is fully 100% given to flywheel. So flywheel is going to start to store the mechanical rotational energy, right? During the parking period, right? See, in parking station, in what is it? Sorry, not parking, traffic signals. In traffic signals, if the particular engine is running unnecessarily in that situation, what is this? Store the energy, right? And the same vehicle is going to run a load landscape and all. In that situation, what is this stored mechanical rotational energy is going to be released from the flywheels, so that in addition with internal combustion engines output power and the flywheels output power, both are given to the wheel, so that the wheel is going to be rotated. That will be tolerate even the road is in the hill stations and all, right? So in that situations, we are going to do some of the control systems aspects. That control system is going to design at which situation the flywheel is going to charge, and at which situation the flywheel is going to discharge the energy at all, right? See, the figure A shows the flywheel discharging, right? See, in that flywheel discharging, see the I hope the figure is visible to all. Figure A, flywheel discharges. The left hand side cylindrical shape shows cylindrical shape diagram is the flywheel arrangement. It is going to release the energy to the system control systems RM, right? Here, through the control systems aspect, the discharged energy from the flywheel will be given into wheels, right? In addition with that, it is going to be used as the energy dissipated in control, brake and all, right? And during the flywheel charging, what is this? Wheel is not going to wheel from the wheel. What is this? Charge is given to flywheel, and the flywheel is going to store the mechanical rotational energy, right? By the way, the flywheel is going to charge and discharging the energy, right? See, just like batteries and ultra capacitors, ultra flywheels is also going to use as the energy storage devices. But ultra flywheels is used to store mechanical rotational energy, and it is going to utilize in a proper way, right? This is also going to use the one of the energy sources, very important energy sources in electric vehicles. Okay, fuel cells. The fuel cell work bypassing the hydrogen through the anode of a fuel cell and oxygen through the cathode. At the anode side, the hydrogen molecules are split into electrons and protons. Like that, with the help of we are getting the free electron. Right? See, a fuel cell works by bypassing hydrogen through the anode of a fuel cell and oxygen through the cathode, right? Here, the hydrogen from the hydrogen tank, hydrogen is going to flow and it will be separated by catalyst and the proton exchange membrane is going to separate it out. So through this, we are getting the free electrons, and the free electrons is going to circulate it through the electrical circuits, right? See, in order to understand, here the animation diagram shows how the fuel cell is going to use it as the energy sources. The same principle is also going to be used in electric vehicle to uh, run the vehicles, right? See, the another case of another energy source of electric vehicle is fuel cell. By the way, the electric vehicle is also getting the okay. Now there are four types of energy sources we discussed. We have to know as a electrical vehicle designer, we have to choose what fuel is going to use it at what time, right? See, comparison of different energy sources. Actually, the Ragon plot is going to use to understand which fuel is going to use at what at which particular situation, right? See, actually, the Ragon plot is used to give the performance comparisons. In order to know the performance comparisons, the engineers are going to determine the following two parameters. One is the specific energy, and another one is specific power. Right? See, we know the specific energy is that watt hour per kilogram, that determines the driving range. With the help of the particular fuel, we have to estimate up to which kilometer the particular electrical vehicle is going to move, right? Or at which particular situation they are going to charge, right? That determines the driving range, right? See, this arrangement, this facility is available even in present current vehicles. Even if I had to buy some IC, sort of this Maruti Suzuki Swift Desire and all, that facility is available in dashboard, right? See, the driver is frequently monitored. What's the driving range of the particular vehicle? It is determined based on the fuel availability of the vehicles, right? See, then specific power, that is weight per kilogram. It determines the acceleration rate, right? How the pulling power is going to be developed with the help of the availability of fuel, right? See, with the help of these two things, the Ragoon plot is going to be plotted, and the fuel and various energy sources are going to be analyzed, right? See, this is the Ragoon plot for various energy sources in electric vehicles. Actually, in x-axis, they have taken the specific power, that is weight per kilogram, how much pulling power, how much acceleration power is going to be developed. And in y-axis, they have taken the specific energy, that is the weight hour per kilogram, how long the particular vehicle is going to be operated, right? See, by this comparison, we may notice that fuel cells have more specific energy. Fuel cells always have more specific energy, but specific power is very low. Specific power, weight per kilogram, that is the accelerating power, what the fuel cell is very low. And batteries is somewhat good than the fuel cells. Batteries have somewhat good specific energy, and it's also have the specific power. Right? When we look at the ultra flywheels and ultra capacitors and all, they have very high specific power, but when we compare the specific energy, it is low compared with that of fuel cells and batteries, right? The very poorest cases are ultra capacitors. Ultra capacitors have very high specific power, but what about the specific energy? This is not going to be there. That's why that ultra capacitors and ultra flywheels alone, the electrical vehicle is not going to be designed, right? Some hybridization they are going to make it with the help of batteries and hybrid with that of ultra flywheels, ultra capacitors. And sometimes the fuel cells also, they are going to be collaborated with that, and they have to be used it in appropriate manner. Even sometimes the IC engines also hybrid with that of normal electric vehicle. Then only we can give the performances in better than the cases. So from this,
Hello,
Raghun,
sir.
yes, sir.
Sir, can you tell me what is the difference between specific energy and specific power, and why these are different for all these parts,
Yeah,
battery, fuel
just
cell?
now, just now I told you that specific power is the pulling power, right? Actually, when we look at the track, when we look at the truck and all, the truck have a very higher specific power, right? See, then only they can pull higher amount of load, right? And when we look at the low CC car and bikes and all, they have that much amount, that they have not that much amount of specific power. They have only limited, right? So depends on that applications, right? What vehicle we are designed, right? Actually, it is a pure it is truck related vehicles are very low. That is a commercial vehicle or low weighted vehicle. Depends on that we have to choose what type of fuel is this and all, right? See, normally the ultra capacitors and ultra fuels, they have very high specific power. Pulling power is higher, but specific energy, right? With the help of them, they are not going to run it for longer period, right? See, we know that ultra flywheels and ultra capacitors, they are not going to design much. Even the batteries also, they are not going to give very higher ratings of batteries in electric vehicles. This is the very important aspect. Even nowadays, we just have to think of our mobile phone, right? See, mobile phone also we are using the batteries, right? See, the main drawback, main headache in the mobile phones are what is this charging, right? Uh, the the particular mobile phone is not going to be used for more than 1 day without charging, right? See, every day we are going to charging, right? See, why it is so? Suppose instead of having single battery, if I had to place two number of batteries or three number of batteries in the same mobile phone, we can use it the same mobile phone for more than 3 days without charging point of and all, right? But this is not going to be the feasible, right? The same cases we are using in electric vehicles too, because of this, what is this? We are not going to run the electrical vehicle for longer period, more than 200 kilometers, 300 kilometers, and all. We are not going to run it, right? See, batteries, fuel cells, they have a longer specific energy, but the same cases when we apply heavy load, the same battery is going to be connected with a heavy amount of load up. What is this? Easily the braking, the sorry, discharging has to be taken places. We know that charging and the discharging both are happen in terms of amperes hour. How much amount of current has to be derived from the battery. Normally, when we have to apply very higher amount of load, very enormous amount of current is going to be taken out. Hope you understand what I am explaining. Am I correct, sir?
Got it, sir. Thank you.
Yeah. That's why we have the combinations of ultra flywheels, ultra capacitors, batteries, and fuels and all. Right? See, this is the Ragon chart for comparing various energy sources. Right? Now, at what mode we have to give it? See here, under this hybridization, again the electric vehicles have the following classification: micro hybrid, mild hybrid, full hybrid, and plug-in hybrid electric vehicle, and REV, battery electric vehicle, ultra capacitor electric vehicle, ultra flywheel electric vehicle, and fuel cell electric vehicles and all. Right? See, the first column indicates the vehicle type. What is the vehicle type? And the second column indicates propulsion devices. Right? Propulsion in for normally for micro grid um, uh, up to REV. That is REV stands for range extender electric vehicle. Up to REV, the engine part is there, right? That is internal combustion engine and a motor. Both are going to be operated, right? range extension electric vehicles. Then for battery electric vehicles, ultra capacitor, ultra fuel cells, and fuel electric vehicles and all, or fuel cell electric vehicles and all, not going to use the internal combustion engines, right? See, the propulsion devices have the classifications, how much proportions we are going to use it in the internal combustion engines and how much proportions we are going to use it in the normal electrical drive, right? And the second and the next column indicates the energy carriers, right? For energy carriers, in mild hybrid, they are using the liquid fuel, right? Liquid fuel means just like petrol, diesel and all, right? Even LPG also they are going to use it. And what type of carriers? Normally for battery electric vehicles, they are going to use the electricity. And what is the energy sources? And again, the energy sources for this case, fuel electric vehicles, they are using fuel cell. Ultra fuel cell electric vehicle is using ultra flywheels. Sorry, UFEV, ultra flywheel electric vehicle and ultra capacitor electric vehicle, they use the only ultra capacitors. In addition with that, battery is also going to be incorporated in the hybridization, right? So by various combinations of energy sources, the electric vehicles are going to be designed and it has the classifications. It classifies from micro hybrid to full fuel electric vehicles, right? See, this is the table how the electric vehicles are hybridized, and in that hybridization, what is the propulsion type, energy carriers, and what are the energy sources shown in this table. Okay, then we by the comparisons of micro hybrid, mild hybrid, full hybrid, plug-in hybrid electric vehicle, and range extension electrical vehicle, what are the features are going to be used, right? See, normally the features of the electric vehicles are ideal stop or start. We know that as a vehicle, if I have to run means we must have the provision to stop and start instantaneously, right? Ideal stop and start must be there. That feature is available in almost all the hybridization cases like micro, mild, full plug-in hybrid vehicle and range extension hybrid vehicles and all, right? Then regenerative braking system is also going to be there. That regenerative braking, whenever we want to store the energy from the wheels. Again, what is this? Just like the flywheels. In flywheels, they have stored the mechanical energy. In regenerative braking system, they are going to store the electricity. Electrical energy is going to be stored again from the wheels, right? So when we have to apply the regenerative, that facility is also available for almost all the hybridization techniques like micro, mild, full, plug-in hybrid vehicle and range extension vehicles. Then power assist is not going to be there in micro hybridization, and electric launch is also not be there in micro and mild, and efficiency optimization is there in full PHEV and range extension vehicle, and decent electrical range is available in plug-in hybrid vehicles and range extension electrical vehicle, right? See here, the efficiency optimization is then and there we had to optimize, then and there we had to analyze instantaneously, right? See, that facility is also available nowadays in the car like Maruti Suzuki Dzire and all. They have instantaneously calculate what is the performance of the particular vehicle, right? What is the consumption of a particular instant like 1 kilometer or 1.5 kilometer. They have to take the average, right? That facility is also going to be there in PHEV or EV. By these combinations, what is the performances of batteries? What is the performance? Hello. I received some disturbances from audience, right? Kindly mute your audio.
Sir, please continue.
I think sir has muted himself.
Mhm.
Audible, sir. Sir, not audible. Please.
Yeah, organizer.
Yes, yes.
Yeah, kindly mute participants and don't forget to unmute me. Right. If you again you mute me, I couldn't speak. Right. Okay. See, whenever I have to share my screen, it is very difficulty to come back and again transferring mute to unmute situations. Hope you understand. Yeah, this is what we discussed. Features available in electric vehicle and how they are capable in various hybridization technique like micro, mild, full plug-in hybrid vehicle and range extension electric vehicles. Right. Then comparison of energy diversifications between various electric vehicles and internal combustion engines. Right. See, this is the block diagram. It shows the combinations of internal combustion engines and battery stored vehicles. Right? See, normally we know that internal combustion engine is going to be operated with any fuels like oil, natural gases. Right? See, oil, natural gases, these are all given to that liquid fuels and gaseous fuels, and by that internal process, the power, mechanical power, will be produced with the help of internal combustion engines. And conventional hybrid electric vehicles have the both cases, right? See, the power from ICEV and the power from batteries, right? And batteries are going to charged with the help of again with the help of biomass, coal, nuclear, hydro, wind, solar, ocean, thermal power plant, and all. Right? See, from the various sources, just we had to getting the electricity, and electricity is going to be obtained, and it is going to be stored in the battery, right? And see, from that battery, what is this? The battery, sorry, the electricity is going to be obtained from the, we know there is power plant, we teaching to the students, biomass, coal, nuclear, hydro, wind, solar, ocean, and geothermal. We are going to getting the electrical power, right? Just we are converting mechanical power into electrical power, and the electricity is going to be used as the energy carriers like hydrogen. What is this? See, electricity is going to use in the following cases, right? Battery electric vehicles, ultra capacitor electric vehicles, ultra flywheel electric vehicles, and fuel electric vehicles. Again, the functional block diagram classifies into the following three category: energy resources. What are the energy resources available? See, the energy resources are oil, natural gas, biomass, coal, nuclear, hydro, wind, solar, ocean, geothermal, and all. Right. Then energy carriers are what is the liquid fuels we are going to obtain with the help of oil and natural gases, and gaseous fuels is going to be obtained with the help of oil, again, oil and natural gases, and electricity we obtain from those categories. And hydrogen is going to be obtained from sometimes oil and even sometimes coal too, right? And vehicle type, just now I told you that pure internal combustion engine ICEV, that is going to obtain only liquid fuels, and commercial hybrid electric vehicles, that is going to be the combinations of ICEV and battery energy stored cases, battery electric vehicles, ultra capacitor electric vehicle, ultra flywheel electric vehicle, and a fuel electric vehicle. Right? See how this diagram shows how the electric vehicles is going to develop, is going to derive the uh, various energy sources. Right? Okay. Then system configuration of a PEV, pure electric vehicles. See, this is the diagram of a pure electric vehicles. When we look at, it asks the following three blocks. One is the electric propulsion system, energy system, and auxiliary system. Right? See, energy system consists of the following: energy sources, energy refueling unit, and energy management. Right? See, here the duty of the energy source is going to always giving the electricity to the wheel. Right? See how they have to obtain the uh, input. The energy source is going to getting the input from the energy refueling unit. It may be a battery, or it may be a ultra capacitor, or it may be a ultra what is it, fuel cell, whatever may be that. From any of them, they have to obtain the energy, and it will be given into energy sources. And here, the energy management unit is going to decide how much amount of electricity, how much amount of electrical power is going to be fed into the energy sources, and how much amount of energy is going to be retrieved from the regenerative cases, from the flywheels, from the ultra capacitors. Everything are going to be everything are going to be controlled with the help of energy management system, right? Then auxiliary system is going to give the auxiliary power supply to the entire electric vehicles. In addition, it has to give the supply to power steering unit. This is the very important one. With the help of them, only the electrical vehicle is going to run, right? And the temperature control unit, it's also the auxiliary power supply is also going to give the supply to temperature control unit. And electric propulsion system from the energy sources versus power is given into power converter according to what type of motor we are going to use it, whether it is a AC motor or DC motor. Our proper power converters is going to be used, and depends on this pulling power, how much pulling power we have to give it, right? And a particular instant, it may be a slope landslide, or it may be a hill stations, how much amount of electrical power we have to feed it. Everything are going to be desired with the help of power converters, and with the help of electronic controller, power converters are going to be controlled over that. By the way, the electrical motor which is available in electric vehicle is going to be operated, and by this electrical motor, mechanical transmission system is going to be operated. Right? See, this is the system configuration of a pure electric vehicle, and system configuration of a hybrid electric vehicle. Just now I told you that hybrid electric vehicle is the combination of both, right? What is this? Internal combustion engine systems and what is that? Uh, electrical drives, right? Here they have to use the two energy sources. One is from electricity. From the electricity, batteries are going to charges. Uh, Battery charger, with the help of battery charger, batteries are going to be charged over that, and with the help of fuels like petrol or diesel, from the petrol pump, engine is going to be filled with enough fuels, right? Here the power converter is going to operate the particular motor. Power converter is going to operate the particular motor. At what speed we have to give it, what voltage we have to give it, depends on that how much pulling power we have to desire. Everything are controlled with the help of power converter. Based on this, motor is going to be operated. Right? See, from engine, what is this? We know that internal combustion engine. is going to develop the mechanical power. With the help of the mechanical power, mechanical transmission system is going to be produced and it will be applied to wheel. So that, by the way, wheel is going to be operated. So the wheel is going to be rotated with the following two modes. One is from electrical motor and another one is from internal combustion engine. This diagram shows how these two cases are going to getting the energy sources. Okay, then when we look at the comparison of tank to wheels efficiency of battery electric vehicle, fuel electric vehicle, and internal combustion engines. Right. See, the first diagram shows the battery electric vehicles. When we look at the battery electric vehicle, the percentage is the 72%. Right. This is the diagram from comparison of tank to wheels. Tank to wheels means how much amount of power we obtain from the fuel tank, right? From the fuel tank, and how much amount of power we utilized, right? In that cases, battery electric vehicles, in electricity, 100% we obtained, and while we are charging the battery, we know that as an electrical faculties, 2% of energy is going to be wasted out while we are charging, right? Then again, from the battery, motor drive is going to be running. In that situation, again, the motor drive only produced the 78% of the efficiency. Again, from mechanical, again, it is not going to produce 100% of the mechanical power output. Some wastage is there. We all know that without loss, we are not going to convert anything, right? When we have to convert mechanical power into electrical power or vice versa, definitely power loss is going to be happen, right? So while converting electrical energy to mechanical energy, again we are in a position to use the energy. So in motor drive we obtain only 78%. Again, from the motor drive, with the arrangement of some belt or any conveyor, we have to give it to wheels. Wheels only going to rotate it. In wheel only we obtain the performances. Again, that mechanical power is transferring from motor drive to wheels with the help of some belt or conveyor. Again, the power loss is going to be happen, right? In wheels, they obtain only 72%. See, this is the scenario of a battery electric vehicles, right? See, when we consider the internal combustion engines, what is this? In fuel tank, we obtained 100% of performances. 100% we obtained. Again, we have more losses when we have to collect the petrol and diesel, and when we filtering out the process and all. When we have to leave these cases, just we have to consider the performance of electrical vehicles, performance of energy sources from tank to wheels, right? So in tank, we obtain 100% of petrol, right? See that 100% of petrol, when we give it to engine, and if you had to convert, if you had to produce that heat energy, thermal energy into mechanical energy, we obtain only 20%, right? See, 80% of fuel is going to be wasted out, right? So in internal combustion engine, they have produced only 20%. Again, that engine power is going to give it to drive line. In drive line, they obtain only 17%. Again, it will be given into wheels. So in wheels, we obtain only 16%. So just you have to consider in battery electric vehicle, they obtain 72% of efficiency when we applied into wheels. But in internal combustion engine, they obtained only 16%. Right? Then fuel electric vehicles, that is the fuel cell electric vehicles. In hydrogen tank, they obtain 100%. Then we had to split it hydrogen and oxygens. That is protons, that is positive ions and negative ions. In fuel cells, they obtain only 55%. Then with the help of fuel cell, if you have to drive the electrical motor, again losses are going to be happen. So 44% of efficiency performances only we obtain in motor drive. Again, it will be transferred into wheel with the help of some belt or conveyors. 40% of performances only we obtain in wheel. So by this comparison, we easily look into that. With the help of battery electric vehicles, we can achieve more performances. That's why nowadays the people are thinking that when we use electric vehicle, they have a very, very, very minimal running charges. Even you may notice some of the advertisements that if you had to charge for 1 unit or 2 units of battery, you can run the vehicle up to 75 kilometers or up to more than 100 kilometers of two-wheelers and all, right? So it depends on that acceleration power, it may vary, right? Some nominal cases, they are advertising that if you have to charge for 2 units, right? See, we can easily calculate the charging for 2 units. For commercial cases, 1 unit is equal to 7 rupees for Tamil Nadu Electricity Board, and for domestic appliances, they are charging 1 rupees 50 paise, the normal charges for 1 unit. So in that situation, if you have to spend only 3 rupees for traveling more than 100 kilometers at all, that's why the people are thinking about the electric vehicles. But the batteries, fuel cells, and the capacity of batteries they have to give it, and frequent charges needed are the main drawbacks in the cases, right? So this is the comparison of tank to wheels efficiency of battery electric vehicle, fuel electric vehicle, fuel cell electric vehicle, and internal combustion engine electric vehicles, right? Then comparison of well to wheels, from the diesel well, from the fuel well to wheels efficiencies of battery electric vehicles and internal combustion engine shows in this figure. See, in these cases, crude oil 100%, and from crude oil versus oil refinery is going to be taken place. In that cases, they attain only 95%, and for power generation, 36% is going to be happen. And power transmission, again, we know that while we are transmitting the electrical power from one place to another place, again, electrical losses are going to take places. 2% is going to be wasted out. So again, power transmission 34% is going to be there, and the same electrical power is going to be used to charging the battery. We attain only 25%. We attain only 25%. So 25% of charged battery is going to use it in the battery electric vehicle is 18%. But when we go for internal combustion engines, crude oil 100%, oil refinery 87%, oil refinery petrol, and above the cases oil refinery fuels, right? Maybe a diesel. Okay, now. Then diesel is 95%, again the petrol is 87%, and in filling station 83% from vaporization, some more percentage is going to be happen, right? See that 83% of filling station, that is available petrol bank, only we attain 13% efficiencies in the internal combustion engine. Again, it is lower than the battery electric vehicles, right? So comparison of cost premium and the fuel economy of conventional hybrid electrical vehicles. Here in micro hybrid cases, actually here the hybridization. See, so far we discussed so many hybridizations, right? See the availability of four energy sources like a fuel cell, flywheel, ultra flywheel, ultra capacitor, and batteries. We can go for any hybridization, right? See, this diagram shows what is the cost effectiveness of the hybridization, right? See, when we go for micro hybrid, it costs around $300 to $800, and fuel 10 to 15% less in all the cases, full hybrid and mild hybrid, right? Whereas in mild hybrid, the cost involvement for that hybridization is around $1,000 to $2,000, and again, fuel is 15 to 20% less. Again, 15 to 20% less. Then when we go for full hybridization, cost is more than $4,000, right? More than $4,000. But as per that, we can save the fuels 20 to 30% of less fuels. We can get it as compared with that of internal combustion engines. Right? Thank you. Yeah, so far I have explained the introduction part of the electric vehicles. In that introduction part, I explained the various energy sources available for electric vehicles and the comparison of various energy sources and what are the methods available for hybridization, and even in that hybridization, what are the features that they had to be obtained, and what about the performances of each category, right? These are all the cases I discussed so far. Right now, I request the participant, if you have any questions or doubt, please ask me. Yeah, kindly unmute yourself and ask
Hello,
it.
hello, sir.
Yeah, you
Uh,
are audible, sir.
s-
Please.
uh, Sir, can you suggest some of the online sources where we can get any data related to electric vehicle,
Yeah,
which is
actually,
freely available or?
it's a freely available. Actually, I get it from NPTEL course material, right? Actually, I have attended two number of NPTEL course related with the electric vehicles. In that only I have collected so many books. Anyhow, after completing this, I will give the reference books related with the electric vehicles. That has that will give a enormous amount of insights into the electric vehicles.
Uh, no, sir. I mean charging station data like EV arrival time or departure time, like any charging stations data, electric vehicle data.
Yeah, charging station. Now the research are going on. Anyhow, my next topic is only about the battery charging technologies. What are the technologies available and how? What are the challenges, opportunities, everything? I will explain. Anyhow, in forthcoming presentations, I will share the details about the charging stations and difficulties, challenges, and opportunities.
Okay, sir. Thank you.
Yeah, thank you. Any questions, please raise. Yeah, after completing my session, actually for each and every session, feedback session is there. You have to fill up the feedback, right? Actually, the feedback link will be shared in WhatsApp group, right? According to the responses of feedback received and attendance in Microsoft Team, your attendance is going to be uploaded in ACT ATAL website, right? For each and every day, we are in a position to upload the attendance details, right? So only with the supporting of feedback and attendance we downloaded from Microsoft Team, we had to upload it. So I request all the participants kindly attend all the sessions and kindly give your feedback, right? So my team will share the feedback link in the WhatsApp group. Srividya, I don't know whether she's there or not.
Hello, sir.
Dr. Srividya or Vishwanath. Vishwanath, are you there?
Yes, sir.
Yeah, kindly share the feedback link to WhatsApp group, right? And you have to give the you have to fix some target time, right? Before 9 p.m. today. Within that, the participants are going to give the feedback, right? By this feedback and session attendance, we can upload the attendance details to ACP ATAL web portal. Okay.
Okay, sir.
Hello, sir.
Yeah. Tell me, sir.
Small doubt, sir.
Yeah, please.
As I'm pursuing PhD in Bijapatnam University in
Okay.
electrical vehicle.
Yeah.
So for any converters, DC converter is there, sir. DC converters.
Yes, sir.
Only buck converter, boost converter using, or any multi-input DC converter also
So
using?
actually, there are plenty of converters available in power electronics sites. We all know
Okay.
that. Only the application is electric vehicle, right? So in that applications, we have to concentrate what type of vehicle is this and how much amount of pulling power actually the particular electric vehicle is needed. Based on this, power converters are going to be used, right? Anyhow, Dr. Kribakaran is there. Is the professor and head of the department, St. Joseph Engineering College.
Okay.
He is working in the areas of power controllers. He is
Okay.
going to take one more session related with that. Hope you will get clarifications from from his session.
Okay, sir.
You
Thank
will
you, sir.
get more insights from the session.
Okay, sir. So what is the new, actually, the converters is there, sir? Different type of converters, the multi-input DC converter topologies.
Yeah.
But here, electrical coupled multi-input converters or magnetic coupled multi-input converters. So which is best, sir? Which is applicable for that one?
Sir, I don't know the correct
Okay.
answer for that.
Okay.
Anyhow, the session will be there related with the power converters,
Okay,
controllers,
sir.
and resource person is working in that area, right?
Okay,
Better
sir.
you will ask the same questions to the particular session. The resource person name is Dr. D. Kribakaran, right?
Prabhakar.
Hope,
Okay, thank.
yeah, Kribakaran. Hope
Okay,
day after tomorrow he is going to take the session. You will
okay.
get more explanations from them.
Okay, thank you, sir.
Yeah. Yeah, hope there is no further questions from participants. Yeah, thank you all participants for your passion listening. And as a coordinator, I am again insisting you that in order to get a certificate from AACP ATAL report, you have to be present. You have to be maintain at least 80 percentage of attendance in for all the 5 days put together. So, and in addition with that, you have to secure more than 60 percentage of mark in assessment. Actually, the assessment is going to be happen at the end of the day before validity function. So I request all the participants to attend all the sessions. If you have any difficulties in attending the session, kindly contact our team members. Right? I will hope you will get all the details, all the coordinator phone number, contact details in the WhatsApp group. Right. In addition with that, kindly log in with the login ID, username, password provided by K.S.Rangasamy College of Technology. Instead, if you have to join with your name or your organization ID, it is quite difficulty to understand, quite difficulty to get the uh, uh, correct attendance details. Even sometimes you may attended the session, but fortunately, mistakenly, we have uploaded the attendance details as absent. So I request all the participants to use the login ID, username, password, which are provided by K.S.Rangasamy College of Technology. Even if you have any problem with that login ID, password, our team will guiding you. Thank you. Thank you, Anandal. Over to MOC.
Thank you, sir, for sharing your expertise in the field of introduction to electric vehicle, and we are delighted to have glimpse of topic from you. We could like to inform that the next section will start around 3 p.m. Thank you.
Thank you, Ma. Thank you.